All right, let's go on to the next lesson of maths, and that would be the multiplication and division of rational expressions. As long as you know how to work with multiplication and division with fractions, this here would be very easy as well. So let me put the title on for you now. So this title here would be multiplying, and dividing rational expressions. All right, and we'll start off with a little bit of, well, I don't even need to start with a note. What I can do is just go straight into the steps because you already know what a rational expression is. So let me just put this as white. To multiply rational expressions, what we're going to do is we're going to first factorize all numerators and denominators. The second thing that we're going to do is to cancel common factors between numerators and denominators. Then the next thing that we're going to do is we're going to multiply all numerators to get the result, well, the resulting numerator, and then 4, we're going to multiply all denominators to get the resulting denominator. All right, once we're finished with that, then we're going to factorize and simplify result if necessary. All right, so very simple, easy steps to follow, and these steps are the exact same that you would see when you're doing fractions. You would usually factorize the fractions as well and cancel off the common factors just to help simplify the work that you have to do. Now, let me say right away, as long as you know how to do this, then the steps for division is very simple. So let's say to divide rational expressions, what we're going to do is we're going to rewrite as a multiplication problem. And you know how to rewrite as a multiplication problem. So say, for example, if we have something like a over b times c over d, sorry, not divide, not times, divide. All right, so if we have a over b divided by c over d, then this here would be rewritten as a over b multiplied by d over c. And that's all you have to do there. Once you have this rewritten, then the next thing you have to do is, we just put this at the end here. Right. Once you did that, the next thing you have to do is you just simply have to follow multiplication steps. All right. And this is, as I said, very straightforward. So I'm going to do the examples, and it's going to be a mix of division and multiplication. And let's face it, as long as you rewrite, you'll be getting a lot more multiplication practice than division practice. All right, so let's start with the first example. I'll put this here. So let's say this is example 1. And let's start off something very simple. Let's say 2 over x multiplied by 3 over 5. And this here is very close to looking like a fraction, except for this 2 on the underneath here. So what we do is we follow the same rules as fractions. 2 times 3 divided by x times 5. And we're going to get 6 over 5x, and that's the answer. Let's go on to another one. All right, so now that you understand we're looking at fractions, let's make the rational expressions a little bit more complicated. Let's say, for instance, we have x divided by x plus 1. multiplied by x plus 1 over 2. Notice that we have a factor here that is common to the top and the bottom. In other words, the numerator and denominator. We multiply the remainders, which is x times 1 and 1 times 2, x times 1 and 1 times 2 to get the answer of x over 2. All right, let's make it a little bit more difficult now. We'll do it as a division. So example number 3. Let's say we have something like x squared minus 1 divided by x plus 2 divided by x minus 1 over x minus 2. So that is x squared minus 1 over x plus 2 divided by x minus 1 over x minus 2. And again, it's a very simple thing to do. We just simply rewrite first. So I'm going to rewrite, and I'm going to get that x squared minus 1 over x plus 2 multiplied by x minus 2 over x minus 1. And now what I'm going to do is I'm going to follow the first step that I said in multiplication, which is to factorize. We're going to factorize, and I'm going to get that, well, I'm going to factorize x squared minus 1. Now I have to recognize this is the difference of squares, so I will say x plus 1, x minus 1, and then rewrite again. So x plus 1, x minus 1, x plus 2 times x minus 2, x minus 1. So I can cancel this with this, and then I will have x plus 1 into x minus 2 all over x plus 2. And I'm going to leave it as it is because it's factorized and it's simplified. All right, let's go on to another one. Example 4. Example 4 is as follows. Let's say 2x squared minus 8 divided by x squared minus 4x plus 4. And let's put this multiplying by x squared minus 4 all over 4x squared minus 16. All right, so first thing we want to do is we want to factorize. So I'm going to say factorize. I'm going to start with the first one, which is 2x squared minus 8, and I'm going to recognize that this can be rewritten as 2 into x squared minus 4. And I can recognize this as the difference of two squares, so this here would be equivalent to 2 into x plus 2 into x minus 2. That's the first one. Let's see this one. I can try and see if I can factorize this. I can see 2 by 2, so I'm thinking to myself, x squared minus 4x plus 4, and this here would be equivalent to x into x, and I can just say 2, and I say minus 2, so I will now get x minus 2, and as you can see, this is a perfect square, so it's x minus 2 all squared. So I can rewrite this as well. Then let's look at this. I can see that x squared minus 4 is equivalent to x minus 2 into x plus 2. This is a difference of squares. Let's check this last one. 4x squared minus 16. I can see that this is equivalent to difference of two squares again, 2x minus 4 into 2x plus 4. I can probably pull out a 2 as well, or I can pull out 4. And in fact, let me do it that way. I can simply pull out 4 here first, leaving me with x squared minus 4, and then I can say this is equivalent to 4 into x plus 2 into x minus 2. All right, now that I have all the factors, I can just simply replace where necessary. So I'm going to put in here 2 into x plus 2 into x minus 2. Then I replace the other one, which is this one here, with let's see, x minus 2 squared multiplying by, I'm replacing this one here now. This one here is x minus 2 into x plus 2. And then we have this one here now. I'm replacing it with that. So I'm going to have 4 into x plus 2 into x minus 2. All right, let's do some cancellations. We can see one of this will cancel with one of this. One of this will cancel with one of this. One of this will cancel with one of this. And I will remain with 2 into x plus 2, close bracket. Oh, there's a 2 here as well. So 2 into this is 1 and 2 into this is 2. So I can get rid of this here. And this on top is 1, so this is that by 1, which is just simply x plus 2. And then I have on the denominator, I have 2 into x minus 2, since I remain with 1 after cancelling off 1 with the top. And this will be my final answer. It's in its simplest form right now, so that's it. All right, this was what, the fourth example. That was pretty complicated. Let's do one last one, but it's not going to be so difficult. Let's say example 5. Let's say example 5, and we have what? X squared minus 5x plus 6 all over x squared minus 9 divided by x minus 2 over x plus 3. First things we rewrite, so we're going to get x squared minus 5x plus 6 divided by x squared minus 9 multiplied by x plus 3 over x plus 2. Factorizing, let's see, factorize, and we're going to factorize the x squared minus 5x plus 6. And let's see what we get. This here would be equivalent to, oopsie, let me change that color back to yellow. So this here would be equivalent to what? We'll say x here, we'll say x here, and we're trying to figure out factors of 6 that can add to give me negative 5. And they both have to have the same sign because this is a positive 6. So I would say negative 2 with a negative 3, and that will give me a negative 5 when I add them together. That works. Let's see the other one, which is x squared minus 9. Now that would be equivalent to x plus 3 into x minus 3. And that would be it. I can't see anything else factorizing. Let's go ahead and do that substitution. And we'll have x minus 2 into x minus 3 divided by, x plus 3 into x minus 3 times x plus 3 all over x plus 2. Let's do some cancellations. This here would cancel off with this here would cancel off with this, and what I will remain with is x minus 2 over x plus 2. And that will be the answer. All right? Unless, of course, I made a mistake somewhere along the lines. Let me check and see. X plus 3 cancels, minus, then this, oh, this is a minus 2. Yeah, that's a minus 2. This is now positive 2. Yeah, so if this is a minus 2, so then that means this cancels as well. And this here definitely becomes 1. All right? I thought that was weird. Anyway, so now that you understand how to multiply and divide rational expressions, we're ready to start learning a little bit more of the theory. We're familiar with all of the algebra that we'll need to know, or the important algebra, I should say, that we need to know. And we'll move on now to something like remainder theorem and factor theorem, and we'll learn how to use them in the next few lessons. So let's give you some problems so that you can try them. Problems. All right, and the questions are going to be following along the same format from easy to difficult. So let's say 5 over x times 2 over x, and then we have question 2, x plus 3 over x squared minus 9 times x minus 3 over x plus 3. Then we have number 3, let's say we have x squared minus 4 over x squared minus x minus 6 divided by x minus 2 over x plus 2. Let's say x squared minus 9 over x squared minus 4x plus 4 multiplied by x squared minus 2x all over x squared minus 3x minus 10. And then for number 5, let's give it a really difficult one. So x squared minus 4x plus 3 all over x squared minus 9 divided by x minus 3 divided by x all over x minus 1. And these are the problems. So I will see you tomorrow for the next lesson, which is going to be on remainder theorem. Enjoy the rest of the evening.